Hello class, this is a video tutorial on trigonometry. In this video we're going to be looking at combining true bearings and trigonometry. So most of these questions will follow a general pattern. The first one is you're going to interpret a description to a graph, and then we're going to either calculate a missing angle or a missing side length. The thing that we have to know is whenever you hear or read, or rather, if you read due north or due south or east or west, what it means is a direct line to the starting point. And this will make a lot more sense as we do a few examples here. So here we go. Example A. A boat sails on a bearing of 105 degrees true for 3 kilometers. How far south has the ship sailed? Okay, so first we need to interpret this graph, interpret this description into a graph. So how we go about doing this is, for this you're going to need a lot of space. What you do is you go from the middle of the area that you're going to work in. So I'm going to go just about here. So I'm going to draw a compass rose in the middle of my page, like so, and just label this way as north. And now we need to draw this line, or find the direction of 105. Well, this is 90, so 105 is just past 90. It does not have to be exact, just need to do an approximation. So let's say that if this here is 90, so if I have to draw a line this way, that's 90 degrees, true. So 105, we'll say, is about here. And they sailed for 3 kilometers. So from the starting point, here in the middle of the compass rose, let's draw a line, like so. And we'll label this as 3 kilometers. Now the interesting part is we know that from north, going clockwise, this here is 105 degrees. But if we were now to try and solve the question here, how far south has the ship sailed? Really, from the starting point south is this way. So what it's asking us, if it ends here, how far is this length here? Because this is now directly south from the start point. So if we were to draw a line perpendicular to this way, which is south, what the question is really asking of us now is this length here, x. As you can sort of see, we are developing a right angle triangle where we have one side and the hypotenuse, because if this is 90 degrees, the hypotenuse is this way, is this length here. So all we need now is an angle. Now here's the interesting part again that you need to put your thinking caps in. Well, if that's 105, then this here must be 90, which means this little bit here must be 15 degrees, because 90 plus 15 gives me 105. So this here is 15 degrees. Well, if this here is 15 degrees, there are 2 angles we can work with. We can use this angle, or we can use this angle. I want you to see if you can figure out what this angle or this angle is equal to. You can pause the video and give it a go. Now, here's the answer. Well, since this line here is parallel to this line, we can say that this angle and this angle are alternate angles, which means this angle here is 15 degrees. Another way we can do this, hang on, let me clean this up just a little bit. This is 15 degrees. Another way we can look at this, I'm going to answer this angle now. Well, if this angle here between south and east, that must be 90 degrees. So if this is 90, this angle here is 15. This angle should add up to 90, so 15 plus this angle should equal 90, which means that this missing angle in this spot here must be 75 degrees. So now we have two angles we can work with to solve the same question. I'm going to go both ways for this, and let's answer it like so. If we use this angle, it's going to be x and 3. But from this angle, x is opposite, and the 3 kilometers is the hypotenuse. So opposite, hypotenuse, so sine 15 must be x over 3 kilometers. Solving this, we can multiply both sides by 3, so we get 3 sine 15 equals x. And inputting this into our calculator, we get x is equal to 3 sine 15 degrees. Okay, well, if that is 3 kilometers, how far south have they gone? 0.7764. Which rounding this off to 2 decimal places, we get 0.78 kilometers. Now, the reason why I put the 75 here is we can answer this using this angle, and we'll get the same conclusion. So from 75 we have x, which is adjacent, and 3 kilometers, this line here, which is still the hypotenuse. So adjacent and hypotenuse uses cos of 75 is equal to x over 3. Multiplying both sides by 3, we get 3 cos 75 equals x, which tells us x is equal to, using our calculator, 3 cos 75. And what do you know? We get the same answer. Which gives us 0.78 kilometers. This is to 2 decimal places. 2 decimal places. This is just one example of 4. And in the next few examples, I invite you to pause the video and give it a go yourselves. See you in the next one. Good luck!